Hi, my name is Nathaniel with Kaeley and Leighanne, and today we're going to be talking about different ways to solve quadratic expressions. Alright, so our first method here is difference of two squares. So what you'll notice first about these problems is there's at least one square, as you see the x squares, and there is also another number that is being subtracted, difference. So first off, we're going to look at our first problem, and it is x squared minus 16. So you're going to look at like things you can take out. So you can take a square out of both because 16 is a square. The square root of 16 is 4. So you're going to write an x minus 4. That's just one side of the equation because there have to be two equations to multiply together to get these answers. And a negative multiplied to a positive equals a negative. So what we're going to do here is pull another x out. So now you have your x squares if you were going to multiply the two together, and you have a positive 4. There you go, that's how you get x squared minus 16. Alright, moving on, now we have another number in front of your x squared. So we're going to take out a square again, and the square root of 4 is 2. Square root of x squared is x minus the square root of 25 is 5. Alright, but that is only 1/2. You aren't done once you come to this point. You have to have the other side of the equation that it multiplies to. So you'll have another 2x because 4x squared is positive. And you'll have a positive 5 because a positive times a negative gets you a negative. Alright, coming to our last equation. Here we have 81x squared minus 1. Alright, so we can tell that square root of 1 is just 1, so we don't really have to worry about that. Just remember your sign rules. But we come to 81x squared. So we look at the square root of 81 is 9. X squared is x. And we have our minus 1. You just need to remember that once you get to this point, you aren't done, because you still have the other side of the equation that it multiplies to get these squares. And a positive 1. So your answer is 9x squared minus 1 times 9x, 9x, forget the square right there. And yep, that is how you solve difference of squares. That's how you use it to solve quadratic expressions.
Now I'm going to teach you how to solve quadratic equations using the GCF method. In the GCF method, you have to take out like terms. So in our first equation, a like term is 2, because we can take it out of both sides, and an x. After that, you write the remainder of what is left in your equation, which is x plus 2. So your equation is 2x times x plus 2. In our next equation, we can take out 2xy, and our remainder is x minus 2y squared. And that is how you solve equations using the GCF method.
Okay, so I'm going to teach you how to do the AC Murph method. Here we have x squared plus 8x plus 15. You want to start by making your little x here, and you want to multiply the 15 times the 1, and you'll get 15. And then you'll bring the 8 down. And now you want to find something that multiplies to 15 but adds to 8, which will be 5 and 3. So And since you don't have anything in front of your x, you can go ahead and make it x plus 5 and x plus 2. Actually, it will equal x plus 5 and x plus 3. Okay, so now we're going to do the hard Murph. So you want to, again, make your little x and multiply the 9. And now you have a 2 in front of the x, so you'll multiply the 9 and the 2, and you'll get 18. And then you want to bring the 9 down here. So what times what equals 18, but adds to 9. And you get 6 and 3. And so since you have something in front of your x, you want to go ahead and write it out. 2x squared plus 6x plus 3x plus 9. Finally, you want to GCF both equations, and you will get a 2x parentheses x plus 3, and then you will get 3 parentheses x plus 3. Inside the parentheses, you want to make sure that you have the same equation, the same numbers inside the parentheses on both equations. And then you will just go ahead and put x plus 3 as one equation, and then you will put the 2x plus 3 in another parentheses. And that is the final step.